Welcome to this module on putting together all the pieces we learned in the VCN lecture series. My name is Rohit Rai and I'm part of the Oracle Cloud Infrastructure team. So let's review all the concepts we have gone through until now. So first thing is subnets can have one route table. We looked into this and multiple security lists. Now this number, of course, this is the default, but you can always change it by opening a request with us. Route tables define what can be routed out of the VCN. You don't need a local rule because the traffic is already allowed inside the VCN, but it basically decides what kind of traffic can be routed out of the VCN. Private subnets are recommended to have individual route tables to control the flow of traffic outside the VCN, and not just their own route tables, but also security list. So your things are much cleaner. You don't mix and match private and public subnets. All hosts within the VCN can route to all other hosts in a VCN. There is no local route rule required. Now this is great because otherwise you would be writing local route rules to allow the traffic. Now the thing to keep in mind is even though this is true, you still the host within two subnets cannot talk to each other unless you open specific ports. So or unless you make changes to the security list. Security list manage connectivity north south, so whether it's incoming outgoing to the VCN and east west. So this is what I was just saying, internal VCN traffic between multiple subnets, you still would need to operate on the security list and make changes for the traffic to flow between them. OCI follows a whitelist model, which means that you must manually specify whitelisted traffic flows. By default, things are locked down, like I was saying, right? Even if two instances are in the subnets within the same VCN, it's not automatically, the traffic is not allowed between them. In fact, instances cannot communicate with other instances even in the same subnet unless you permit them to. So you can test this out, and this is going back to the whitelisting model we were talking about earlier. Final thing, we looked into this in the previous module. Oracle recommends using network security groups instead of security list because network security groups lets you separate the VCN subnet architecture from your application security requirement. What does that mean? Two instances in the same subnet with security list need to have the same security posture, meaning incoming outgoing traffic on specific ports have to be the same. In case of network security group, that's not a requirement, that's not a restriction. You could have different kind of traffic, different ports, different protocols, different destinations and source supported, even though those two instances are in the same subnet. So let's look into this from a sort of a graphical, easy to understand mechanism. We have gone through this in several demos, but it's good to recap here once more. So we have a region, we have a VCN. Just again, for sake of simplicity, I'm not showing ADs. It can be a multi-AD region or it can be a single AD region. We have two subnets here. There's a front end and there's a back end. And again, we have seen this in the previous demo. The front end can be a web server. The back end can be a database server. And of course, the web server is talking to the database server to store the data, retrieve the data, do something there. There can be a middle tier. Again, just for sake of simplicity, I'm keeping it pretty high level. Now, of course, first thing, because front end is a public subnet, it has its own route table, and backend is a private subnet, it has its own route table. Similarly, front end has its own security list, backend has its own security list, right? Pretty straightforward. So what is front end's requirement? The front end requirement, it's a web server, it has a public IP, it wants to go to the internet, people should be able to pick the web server, so it has traffic going to the internet gateway. Now, in case of the backend, we don't want to allow that kind of traffic, right? We don't want to allow the traffic to go to the internet. But in this case, it could go to a NAT gateway, it could go to a service gateway, because let's say NAT, it wants to get some updates and patches from the web. In case of service gateway, probably it wants to go to the object storage to do a backup, for example, right? So what do the entries look like? So for this, for the front end route table, basically we are allowing traffic from all packets, from all addresses, to go to the internet gateway, right? We looked into this in the previous modules. Pretty straightforward, right? What kind of security list we are using here, right? Ingress, we are saying traffic from all IP coming at port 80 is allowed, right? It's a web server. And then traffic going out, we are locking down the default traffic going all the to everywhere. We are saying the traffic is only going to this particular CIDR and only on port 1521. Now, one thing you would notice here, I'm still using security list, but you could have used a network security group here, right? There's no requirement which says you just have to use security list. Now, in case of the backend, again, I'm saying traffic going to all IP addresses, all kind of any IP address can go to a NAT, can go to a service gateway, or even can go to a DRG. If I'm going, like, if let's say this is my on-prem, I want this traffic to go to my on-prem environment, I could do that. So this is the kind of traffic which is flowing here. Right now I'm not doing any of this, right? So this is like a complete blank here, which is fine. But you could have traffic going to different gateways. And for my security list, I'm saying my ingress is this particular CIDR block. So the traffic is coming from here on port 1521. And again, important thing to keep in mind, I'm blocking all the other traffic. By default, this is always there in my security list, which says that all kind of traffic is always allowed out but never allowed in, except for a couple of ports, like if you're using a default security list, port 22 is open, etc. But in this case, I'm saying I'm locking out all the traffic. I don't want any traffic to go from here. I just want traffic to go to this to the front end, right? And because it's all stateful, if my packets are coming in at 1521 port, they're also going out from 1521, right? So I don't have to write a separate egress rule. If this was stateless, I would have to do that, right? Really straightforward setup. We have seen this in the previous demos, so hopefully it gives you again a recap of some of the concepts we have gone through. Well, with that, thank you so much for joining this lecture series on virtual cloud network. Virtual cloud network is one of the core concepts you need to understand in cloud, and of course for OCI. I hope this was useful. If you have time, please join me in the next lecture series on compute. Thank you.